Okay, hello together. I hope everything is awake. I'm not head of the ISO committee, I'm head of the analytical lab from Agose in Pforzheim. We are a producer from silver bars. We also a refiner. Our refining volume for the silver bars is, the refining volume is 1,000 tons per year. Last year we produced 300 tons from these accurate silver bars. You can also use the silver bars not only for walls or investment, you can also use it for decoration purposes in living rooms and lounges. One bar looks after the other. Since 2013, our production produces more than 40,000 tons from these bars. And we are totally sure that all of these bars had oxygen contents then lower than 25 parts per million. That is be sure. So, now we started with the work from the ISO group. This is the short agenda, what I say to you. The last information you get about the ISO group was 4 years ago. Thomas Brodmann makes a presentation about the old norms and the difficult work in this ISO group. Since that, a lot of things changed. And we get a new convener, we get a new secretary, Petra Bischoff from the Dean in Pforzheim. We also had since 1 year a new chairman, Jonathan Yodri. This is now the actual organization of this ISO group. We had 2 working groups. One working group is the working group 1, methods for determination of fineness in jewelry. The other working group is for colored from gold alloys. In 2013, Thomas Brodmann closed with the words, "I hope once the organization problems are settled and the work can go on." I think it runs now. After a year of findings, I think we had a very powerful working group with a lot of experience also from older people like me and younger people like the other one. The ISO is, you have in the ISO, you have the participating members and you have observing members. The participating members play an active role in the working group, and the observing members follow a development of standards. This ISO working group has 20 P members and 17 O members. In the brackets, you see the national bodies who represent it in the national countries. If there are any questions, you can contact Petra Bischoff by the Dean in Germany. She is the secretary of the working group, or also Jonathan or myself. That is not a problem. So, how develop a standard or norm? You had there mandatory and optional. The working group has the proposal stage, preparation stage, and the committee stage. This is part of the working group. You have the comments, the round robins, and so on. After that, there is an inquiry stage, and then it goes to the national mirror committees, and then it goes to publication. You see a long way, a hard way, but a very interesting way if you had so a good working group like this one. Here is an overview about the published standards from the ISO TC 174. You see here, this is the first one, this 9202, the fineness of precious metals. The other one are all determination in different kind of alloys, gravimetric, cobellation, volume titration, ICP. And you see the stage, all stage have 16. This means all of these norms are public. You see, these are the different stages, and you see every norm has now the 16th stage. You see here the red one. I will go more in the deep by this 2-1. This is the determination of precious metals in gold, in silver, by different method using. So this is also an overview from this ISO norm 9202, you had here the precious metal, you had the fineness, and you had a recommended method for the determination from the fineness in this method. You see this cobulation for these gold alloys. For the 99 gold, you can use cobulation or ICP. For platinum, it's gravimetric or ICP, and for the 99, it's ICP. For palladium, the same, and for silver, you have the potentiometric titration, and also for the 39 silver, you have the ICP. So last year, after I cannot remember when the last round robin was, so we started last year in September, a round robin. We decided to make determination of platinum by ICP, also to check how practicable is the ISO 15093 and the 15096. So we had a team with 4 people. Jonathan looked for the gold alloy. Steve Humbert from the Swiss Custom Control had material for platinum alloy, and our production, we had a very good silver, fine silver, to check that. And Petra Bischoff makes the organization of that. The aim was to check the practicability of the methods as described, and all of the members should work as described in the method. So we would get a little bit information, how does it work in the daily work. This is the scope for the gold. You see, very easy principle. Dissolve in aqua regia and measurement by ICP. Very easy. When I got the first results from Steve, I was totally surprised because you see, it's very easy. But look here at the Z-score. What happens? We did not know exact. For 39 metals, it's okay. You have only 20 ppm when you take the averages, but when you have here these Z-scores, it looks not so good. So then we looked problems with calibration, problems with detection from non-present metals. Someone detect metals that are not present. Cross-contamination, someone cut the wire with a knife and had found iron inside, and so on. But also very high ranges for the silver, for the copper. The material was homogeneous. Jonathan took this material. This was approved by our round robins, and this was only the working from the norm and the daily work from the different kind of labs what we see for this method. For the silver, you heard a lot of this method yesterday from Alessandro Ruffoni. You dissolve the sample in nitric acid, then you get a 10 gram per liter solution. The suspension, if some suspension is present, is filtrated. And then you had a nitric acid solution with silver, and you had an aqua regia solution with tin and gold and the rest. And then you make the reduction by 1000. Here you look for the results. This looks good, but why? This method is much more complicated than the other one. I don't know. Cannot say. So what we see here we had very interesting things. Also, we see problems with calibration and blanks. But what we also see, that are also determination problems with detection from non-present metals. And when you look here, all of the refiners from you who make 4-9 metals, if you say tellurium 3 ppm plus minus 4, the bell should be ringing. Also, when you see bismuth 5.8 plus minus 7, also the bell should be ringing. I will show you something about that topics later, but I think it's depend on that a lot of the labs had LODs and LOQs like a, let me say, good feeling practice. not defined well. And that's also because we had only a 10 gram per liter solution and we used that materials, and that is part of the daily work and the quality control, and the ASTM said a lot of materials must be lower than 5 in the production control for 4.9. So we see we get also a lot of information about how we handle it in the future. And now I also want to say thanks. First is Steve Humbert. He make a total fantastic statistic evaluation. Every from the group who get the report said this, and he spent a lot of time for that. And he cannot be here today, but without his work, it would be impossible to have this information. Also, Petra Bischoff for the permanent help and support, and Jonathan also, we four work together very good in this team, and also for the members of the working group. A lot of the members are here in the room at the moment. I hope they fill all up their memories for tomorrow, that we have an intensive meeting, because tomorrow this ISO group has a meeting by the London Assay Office. Now I have here an overview. This is the overview about the topics we had tomorrow. We speak about the revision of the ICP norms. We speak about the possibility how these norms can be used for 4.9 metals. We will decide tomorrow to do new round robins, and we will also discuss a primary work item for a standard of XRF in jewelry alloys. That are the topics we had tomorrow by our meeting. Now I will tell you something about, in short way, how to bring these norms in the daily lab working. This is our requirement equipment. We take graduated PP vessels. We take 5.9 materials for the matrix matching. We take an ICP with endon plasma observation, special DA water, analytical reagents with analytical grade. You see, for gold, it's enough. 0.5 gram, dissolve in 50 milliliters, dissolve in aqua regia, and make the measurement here. Very easy. For silver, we see yesterday also a lot from these things from Alessandro. I did not steal him the pictures, these are my own one. We dissolve here, then this is the residue, this is the filter. This is a problem we had to work by his filtration. He makes it yesterday very good in his presentation, and I think we are on a good way that we found a practical solution for all of the members from the working group. You see how you had to work. This is no palladium. For the purpose of demonstration, the solution was dyed red. That you see how it works. These are the used ICPs. We had a Varian Vista Pro endon, and we had a very new SpectroArcos multi-view endon modus. We make the measurement with a common cyclonic spray chamber without internal pipe, also concentric nebulizer. We use common equipment. We had also for the measurement conditions, we use the standard settings from the machine. I think that it can go better. For the gold determination, you see here the recommended lines from the ISO. This is, we call it in Argosy, our powerful program. We use this program, then we get material from new and unknown customers. You see a lot of spectral lines. After measurement, we put these lines in our limbs, and then we can select and look for also spectral interference and so on. For silver, we use that. You also see the green one are the lines that are recommended in the ISO. And now I will not more, because I'm no specialist in statistics, but how we calculate it. We made now the calculation with two methods. You see here, this is the LOD, the LOQ, and the LOQ for the solid material. We make these measurements with this Arcos multi-view in an end-on plasma modus, and you see it's possible with 10 gram per liter to have low limit of quantification. I also have some pictures from the spectrum. You also see tellurium, difficult material. Palladium, zinc, tin. And here I have something special. This is the peak from the proficiency test gold solution. And in case you had no other palladium lines, you would here detect 7 ppm of palladium, but there is no palladium present. This is here from the zirconium. Also the same for silver, the LOD, the LOQ in the liquid, and the LOQ calculated from this, for the solid material in 10 grams per liter with 0.5 gram weight-in. Also here, for cadmium, also for bismuth, also a difficult element, you see high sensitivity. Indium. Attention should be paid. Background correction for each element in each sample must be used. Impurities for matrix matching should be considered. The calculation of LOD and LOQ have been done in real matrix and should be well done. The conclusion, LOD must be known. LOQ must be well defined. QC samples, very important topic, must be used to check the calibration, the chemicals, and the spectrometer settings. In my opinion, it should be possible to analyze gold, silver, platinum, and palladium above 99 fineness with these methods. I'm full of expectation that the working group 1 from the ISO TC create an ISO norm for 4.9 gold and silver. Thank you for your attention.